Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equations. Problem: form partial differential equation from z equal to f of x plus e power y into g of y by eliminating arbitrary functions, the arbitrary functions. So here f and g are arbitrary functions. Okay, we are going to find a partial differential equation by eliminating g and f from it. Let's see. Given z equal to f of x plus e power y into g of x, consider as equation number 1. Now let's partially differentiate it with respect to x. Simply we'll find p, q, r, s, t. Okay. Sometimes we'll find p, q, r and s. We'll just leave r and t. We'll leave s. We'll only find s if it's necessary. Sometimes. Let's see how it goes in the problem. In this problem especially. So I'm going to find p. P is nothing but partial derivative of z with respect to x, right? That is partial derivative of 1 with respect to x. So here we'll partially differentiate with respect to x. I'll just apply dou by dou x on both sides of 1. I'll write it here. Partially differentiating one with respect to x. Just apply dou by dou x on both sides of 1. See, don't feel lazy to write one more step. It's okay. It's okay to write one more step if it gives you a clarity. This gives us dou z by dou x equal to partial derivative of f of x with respect to x is f dash of x plus, here e power y is constant, right? You'll get e power y into partial derivative of g of x is g dash of x, which gives us, here we have a notation, dou z by dou x equal to p. So we'll just replace it by p. We'll get p equal to f dash of x plus e power y into g dash of x. Consider as equation number 2. Okay, now we'll partially differentiate 1 with respect to y. Actually, see, you all know that I have skipped some more steps. I wrote directly. Okay, fine. Now right, this gives us dou z by dou y equal to partial derivative of f of x with respect to y is 0. Since we are partially differentiating with respect to y, so x will be treated as constant. Here f of x also treated as constant, plus g of x can be treated as constant, right? G of x into partial derivative. Partial derivative of this term will be constant. I mean partial derivative of a constant into e power y, right? How we'll write a constant into e power y? We'll just take the constant outside and then we'll write partial derivative of e power y, right? Partial derivative of e power y is again e power y, which gives us, since we have a notation dou z by dou y equal to q, just replace it by q. We'll have q equal to g of x into e power y. Consider as equation number 3. Right, now we'll partially differentiate 2 with respect to x. What will we get if we partially differentiate 2 which is p, right? P is nothing but dou z by dou x, which gives us dou square z by dou x square, which is our r, right? By partially differentiating this or this with respect to x, you will get r, that is dou square z by dou x square. Likewise, if you partially differentiate it, this one or this one, with respect to x, with respect to y, then you'll get q is nothing but dou z by dou y, right? Which gives us dou square z by dou y square, which is rt, right? By partially differentiating this or this with respect to x, you will get r, and by partially differentiating this or this with respect to y, you will get t. Likewise, if you partially differentiate this or this with respect to y, you will get s, or if you partially differentiate this or this equation with respect to x, you will get s. Okay, you can see this in some other problem. Fine. Now we are going to find r and t. Now what I'm going to do is just partially differentiating with respect to x. P is nothing but dou by dou x, right? I'll write it as dou by dou x of, I'll write P as dou z by dou x for my convenience. Okay, you can write P also, but for my convenience I'm writing P as dou z by dou x equal to dou by dou x of RHS part f dash of x plus e power y into g dash of x, which gives us dou square z by dou x square equal to dou by dou x of f dash of x plus dou by dou x of e power y into g dash of x. We have a notation dou square z by dou x square, which is r. Just replace it by r, since dou square z by dou x square equal to r, equal to partial derivative of f dash of x with respect to x is f double dash of x plus, here we are partially differentiating with respect to x, so we will treat e power y as constant. We can write this as e power y into partial derivative of g dash of x, which gives us r equal to f double dash of x plus e power y into partial derivative of g dash of x is with respect to x, right? G double dash of x, right? Which gives us r equal to f double dash of x plus e power y into g double dash of x. This is our r. We got r, right? By partially differentiating p with respect to x, we got r. Now let's find t. Consider as equation number 4 for our convenience, right? Now let's partially differentiate 3 with respect to y. Partially differentiating 3 with respect to y, that is dou by dou y of, I'll write this q as dou z by dou y, since q is dou z by dou y, right? Equal to dou by dou y of the RHS part of 3, q of x into e power y. Since we are differentiating with respect to y, so we'll treat g of x as constant here. This gives us dou square z by dou y square equal to constant into dou by dou y of e power y. Since we have a notation dou square z by dou y square equal to t, we'll replace it by t, equal to g of x into partial derivative of e power y with respect to y is e power y, okay? T equal to g of x into e power y, right? Consider as some equation number 5. Now notice all the 4 equations we have. P equal to f dash of x plus e power y into g dash of x, q equal to g of x into e power y, r equal to f double dash of x plus e power y into g double dash of x t equal to g of x into e power y, right? So we need to form a partial differential equation, right? Now observe equation 3 and equation 5. Okay, now we can take t or either q. I'll take q. Q equal to q equal to g of x into e power y. Since g of x into e power y is t, from this we'll get q equal to t, which is nothing but dou z by dou y equal to dou square z by dou y square, which is the required partial differential equation. Okay, or we can write this as t equal to q or dou square z by dou y square equal to dou z by dou y. Second derivative is equal to first derivative, right? Which is the required partial differential equation. See, by looking at q and t, I mean equation 3 and equation 5, we can say that q equal to t is a partial differential equation and it is not necessary to find s, right? By looking at these equation itself, we can say that s is not required. Okay, fine. Therefore, t equal to q is the required partial differential equation. Or you can say dou square z by dou y square equal to dou z by dou y is the required partial differential equation. All you need to do is we'll find p, we'll find q, r, t, and observe all this. If you feel something or if you feel that you are going to get PDE, that is partial differential equation, using all these 4 equations, then it's not necessary to find s. If you feel it's not available, I mean if you can't find the partial differential equation with the help of these 4 equations, then you'll find s. Okay, we'll see that later. Okay, fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.